The impulse momentum theorem. The change in momentum of an object during a collision equals the force exerted on the object during the collision multiplied by the contact time, which is the length of time that the object touches another during the collision. The same change in momentum can be produced by a large force exerted for a short time or by a small force exerted for a longer time. A quick derivation of this. The net force equals mass times acceleration. We know that acceleration is the derivative of velocity with respect to time, or it's the slope of a velocity versus time graph, so it's delta v over delta t. Delta means final minus initial, so final velocity minus the initial velocity. We can keep t as delta t. So distributing the m to each of these terms gives us m times vf, mass times velocity is momentum, minus mass times vi, momentum, divided by our change in time. Final momentum minus the initial momentum is just delta p over delta t. So on the equation sheet, it's going to look like this. Delta P equals F delta T, or the fat equation. This is accurate as long as you're using a constant force. If the force is not constant, then you're going to have to integrate force with respect to time to get your change in momentum.